Thanks. Our first speaker today is Saverio Fazzari. Saverio works for Booz Allen Hamilton as a senior technical advisor to DARPA and other government agencies. His specialty is advanced circuit design and development strategies with a focus on hardware cybersecurity issues, including trusted design and fabrication. He has over 25 years of experience covering the entire electronic product development flow. He has a BSEE from Johns Hopkins and an MSEE from the University of Pittsburgh. So Saverio, take it away.
Thank you very much, Jeff. So what I'd like to do is first start off and say I have both commercial and design experience, and you may ask, well, why am I involved in a supply chain discussion? The interesting aspect of it is within DoD, especially on the research side and other sponsors I work with, the supply chain question over the last 15 years has become more and more critical because the DoD has viewed this as an interesting problem in that an economic solution is not viable. You need to understand the supply chain, understand the risks, and see what makes sense from there. So what I'd like to do is walk through a presentation and talk a little bit about some of the analysis that's occurred from a Booz Allen perspective, but really highlight some of the issues that are faced from a department as well as some of the research that goes on in that space to give people an idea of how this problem is being looked at from a defense perspective from there. So I'm going to talk about the challenge problems for supply chain issues in DoD. I'll make the case they're somewhat unique relative to the commercial space, talk about some of the past history, some of the current approaches within the department, and some of the tools that Booz Allen uses. But throughout this entire presentation, I will highlight some of the experiences that I've had in terms of the analysis within the space and some of the things that have gone on as such. As was mentioned earlier, if you have any questions, please feel free to post them and provide as such there, and Jeff will ask away. So I think this is a slide, for example, that's used at DARPA, which is the Defense Advanced Research Project Agency, numerous times. That says there's a shift underway to go towards advanced nodes. And within the Department of Defense, they have a similar need and requirement because people tend to think of DoD as building big things. The reality is they build things of every size and they have a need for advanced nodes and technologies as such. The challenge is they have the need for that technology to be deployed and last for an extended period of time, 20, 30, 40, even 50 years. The classic story that we like to talk about is the B-52 bomber that came out in the 50s, which is still flying today and may still be flying for another 15 years or so as such from there, just because it fulfills a mission as such. So the department has a unique requirement in terms of what does it mean from technology as such. So the supply chain is a critical aspect of it. And if you go back a while back, the perspective was, hey, all the parts are built in the US, we don't have to worry about it. Well, in the 80s, there was a push to manage cost. So now that supply chain started to grow. And what you'll see throughout the presentation is what are the implications of a global supply chain? What are the impact as it relates to some of the questions for DoD and potential research and impact as you go forward? So there's a big push and initiative within the department to look at using more advanced nodes. The reality is for the technology that's being developed, the production nodes for digital designs are at 45 nanometer. Global Foundries provides that technology as an onshore fab. Analog is 130 nanometer. I list RF as another piece of key technology, and then rad-hard as a space domain is something which is important to the department as well. And the interesting dynamic is, at least with DoD, and I'm sure people have heard of the desire to have things within the US, is you have a lot of leading edge foundries which are in the United States, both Intel and Samsung, and Global Foundries has capability there. So those are the foundries that provide those advanced nodes. And in many cases, a lot of the requirements for that next generation platform the department wants to build needs those technology nodes. So how do you get access to them? How do you ensure the integrity of the supply and make sure you're successful? One of the challenges, coming from the commercial space that I've seen is that in many cases, the commercial supply chain is important, but that's really for developing product. The threat towards that supply chain being disrupted later on is less of an issue because, the product life cycle may be 5 years, not 50. So what do you do to be successful, especially with a foundry or a supplier that drives down that part from there? A lot of the parts that are used by DoD are COTS parts as such. So now you have this diverse set of components that are being provided from within the global supply chain. How do you understand and go after that stuff as such from there? Advanced microelectronics are a big part of the DoD budget, and that's where they spend a lot of money on different types of components and parts as such from there. One of the things the department is very good at is they have processes and procedures to acquire, to list out what's there and stuff like that from there. And over the last 15 years, they recognized that a lot of those parts were coming from unknown locations as such from there, which may or may not be bad. The concern is if I'm building a commercial product, I can have economic relationships to ensure the integrity of the technology. For a DoD product, they want to make sure that that part is what it does, no more, no less as such from there. So now you begin to wonder, is that part doing what's expected and where to go forward from there? And this idea of trust but verify is an important part of the discussion going forward from there. I think, Ellie, as you notice from this, there's a diverse set of components to go from there. The actual number of technologies that are being consumed may not be significant as somebody like Apple, but a lot of leading edge technology is being used, especially in the RF and the analog space, to go forward from there. So this is one of my favorite charts. This is the DoD acquisition process, which is public knowledge. And this chart is up here more to simply say it is a nightmare to put things together, planning, acquisition. It is the ultimate systems engineering process. It's successful to deliver product things as such. The challenge is when you're talking years to getting the initial product deployed versus a foundry, which may transition from a technology node, or COTS part, which may be replaced in months, you have a problem. So how do you handle the fact that the system you've designed in year 1, in year 6, when you want to deploy it, you've had to replace half the components in it as such from there? And the commentary here written in the middle of the chart is from FY12. So that really pushed an impetus to really understand the dynamics from a technology perspective and try and identify what makes sense from there. So what we'll be talking about is what are some of the analyses being done? What are some of the key parameters that have been identified? So, one of the things that people are proud of is the fact that, a lot of the early work in integrated circuit development was driven by the US military. But over time, the market grew and things like that. So the US military is still a consumer of that technology, but they do not influence the market, say, as an Apple or a Broadcom or an NVIDIA does as such. But they still want to take access and leverage that technology. So how do you do that? How do you manage the supply chain to make sure that you can be effective in the product needs and requirements? So it's a global problem. So what I have here is talking about how do you put together a part and how does that part get manufactured, packaged, go into the printed circuit board, and how does it get distributed back to the appropriate site and location? This is for a weapon system, and you'll notice it just goes over all the world. Now, this be for technical reasons, but it's also for partner reasons in that you want to distribute the cost of a platform so you have partners that help develop a system as such. I'm sure people are aware that, one of the platforms that the United States built was the Joint Strike Fighter with a large number of partners worldwide. So you're passing stuff back and forth throughout the thing. And so within that environment, it just gets touched by so many different people. So one of the concerns is you want to understand the supply chain risk. So one of the things that we did at Booz Allen is say, what can you do from a supply chain perspective? So an easy thing to do is look and understand the companies that are involved and their tools and capabilities to do at that perspective. So if I'm buying from a supplier, for example, does that supplier have knowledge about the technology, or are they simply a storefront and they buy the technology from somebody else. And you want to be able to understand not only the financial viability, but then you want to understand the technical viability of that organization to help support the effort and make sure that the program or effort that's purchasing the part can have access to the technology for the time required. There's been a big push to basically understand what kind of parts do we need? How long do we need it for? And is that supplier a viable supplier? And so one of the things the US asks for is what's the second and third source for the parts? And how do I replace the obsolete parts as I go forward? So one of the things in the 80s, there was a push to drive down costs with outsourcing and segmentation. But now you've got this trust issue that I hinted at from there. Circuit designs, can be built in trusted environments, but in many cases, the fabrication is untrusted. By that, I mean, it's not built in a secure facility that DoD checks off and says, okay, we're good to go from there. In many cases, you can get some trust, but that means it's a specific environment that's set up for a military application. So you don't get the benefits of the commercial environment. So there's some pushes within the department to sort of talk about how do you quantify to enable insurance and leverage commercial capabilities as such from there. So programs and efforts, and when I talk about programs, I'm talking about developing the weapons platform, the system, whatever it might be. Imagine the M1 equivalent that might go into a Air Force drone as such. What does it take to get that built appropriately to go down that path from there? Like, for example, you look at GPS. How do I get GPS built, tested effectively within that design cycle as I go forward, even though the fabrication facility may be different as such from there? But I can't afford to rely on an economic or legal agreement. I need to do more to ensure the integrity of the design information as I go forward. So what you also see here is perceptions of what people view as the threats. Now, many commercial companies say, circuit design, I understand, I'm comfortable with. One of the things that, I've noticed in the 15 years or so that I've worked supporting the government is the physical nature of solutions is critical. People want to touch it to believe it. Commercial industry, if I can simulate it, I feel comfortable with it to go forward from there. So it becomes a little harder as you move forward from there. And I want to make sure that within the supply chain, what can I do to manage and look at and understand the integrity? So interestingly enough, at Booz Allen, we developed a methodology that says, what's the thing that matters to people the most? Can you monetize that information? For example, can you monetize the cost of test? Yes. Can you monetize the engineering knowledge? Can you monetize the cost of parts? And then you can sort of create a risk model that says, okay, what's your confidence that that part will achieve the goal? So there are different ways to think about the problem from there. So again, going back to this issue about supply chain. So these are documents, both instructions as well as an IEEE thing about counterfeit parts from 2012. So this has been going on for years in terms of how do you manage and mitigate the risk to these systems to go into that, because the irony is that military platforms require specific types of parts that are better tested. So you could take an existing part, counterfeiting 101, put on a military grade label and sell it for 10x the price. So now you've got to have techniques to go find that and mitigate the risk of that. And that's not only testing the part, but validating the vendor's effective from there, that the vendor's correct as you go forward from there. So within the supply chain work that we do is how do you help understand the risks and dynamics of where you buy the parts from, stuff like that. And what's compounded here is that the program has a cost budget. So they may be forced in a sense to look at these parts because they meet the cost requirement, even though there's a risk at them being counterfeit. And the cost of validating the parts put you in this awkward position that's a lose-lose no matter what from there. So now if we sort of fast forward to the last few years, it's gotten worse. And, the big hack, it's a wonderful thing to talk about. The fact is that more and more, as technology is more pervasive over the environment, the vulnerabilities are growing everywhere as you go forward from there. The big hacks, some of the things associated with Trojans within aerospace electronics, things as such from there, and the fake parts that exist throughout the system. Because one of the dynamics that I see is just simply put, from a technology perspective, we can identify things, but from a legal perspective, it's hard to prosecute the individuals after that because the legal system is not set up to deal with the evolution within the electronic space. But you have researchers who claim that there are all these various failures in the parts as such, and they have to be researched and qualified one way or the other from there. But from what we've looked at, part of this is just to be intelligent about how you capture the information. And ultimately, it becomes a question of integrating technology information, financial information, and sort of design information to help drive decisions as it relates to the supply chain and identifying risks in the supply chain and what you can do to mitigate that from there. This chart here talks a little bit about some of the threats that might exist out there. And again, traditionally, a lot of work has gone in the hardware security space talking about Trojans that could exist as such from there. You've got counterfeiting, you've got overproduction, which is a common thing to go from there. The theft of intellectual property, which is, I think, probably one of the critical things from there. And, tampering with the parts. One of the challenges is, if you look at the headline, is, we did a survey a number of years ago with commercial versus DoD customers about inadvertent versus malicious methods. And it appeared that the commercial companies were much more concerned about inadvertent methods, where you've had issues with the design due to inadvertent errors that were so hard to connect versus malicious. They said the malicious stuff they don't see, or even if they saw it, they were confident they would catch it. The DoD folks felt that the malicious thing was much more important to them. The most common example, and I apologize for picking on Intel, is the old Pentium bugs that came about a number of years ago from there. So if you look at the design flow, you'll see that there are a number of attack points that can exist along the way. The third-party IP, again, as you diversify the technology, it's easier for people to attack that. So as I want to protect the supply chain from a development perspective, how do I ensure the integrity of that information from there? And when at Booz Allen, we think about the supply chain from concept to actually part delivery as such from there. One of the things that's happened within the department is there's starting to be a push to understand packaging, because packaging is a critical area to sort of take advantage of those advanced nodes, because the reality is it used to be you could buy off-the-shelf packages. Now, realistically, everything is a custom package, and you need to be able to design into that point. In a lot of cases, that capability might be offshore, so you have to determine the integrity of that package and what makes sense to go forward with it from there. So these are just some examples and a draft textbook picture in the lower left-hand corner of some of the attacks that can occur in the hardware security space. And again, these are things that end up in the supply chain, and it's awfully hard to find as such from there. Now, the other aspect of this is, if you have one of these attacks, is it deliberate or is it malicious, or do you really know what's up? Ultimately, part of the problem is, how do you ensure I trust and verify that your technology works the way it does? Because for the DoD customers we deal with, an economic or legal agreement is not sufficient. In many cases, there's liability, i.e. if the foundry does a poor job, or the packaging house or the OSAT does, they lose business and they lose a reputation. Within DoD and their programs, they can't afford to have that kind of failure as such from there. For example, if something fails, they have to find out why it failed, otherwise the system can't operate. So again, the big hack, which I think is, again, I'll be facetious and say the following: everybody uses this chart because it was a wonderful time, at least in this space, both for supply chain and hardware security, to talk about the possibilities. And the irony of this is nobody knows what's true or false, but the reality is it kind of points out the vulnerability of the supply chain, that you have a part there you don't understand, and you recognize that thing's there, and people want to understand what to do about this to ensure the integrity going forward from there. The trade-off is, what can you do within the boundaries of what's available to you for programs? It's easy to solve problems, shall we say, for the future, but what do you do for existing programs and communicate as such from there? So as we work with customers and clients, we try and help identify them options and sort of see what makes sense down that space from there. But the good news, bad news is people recognize this is a problem. You'll see in a couple slides later the dynamic of that. The challenge is, what can you do in a cost-efficient manner that goes across the dynamics where you're cost and time limited? So on the supply chain side, SolarWinds, a great example. That's sort of, I think, took the country by storm, and the dynamic of what matters there, and some of the things that are posted on the web about, hey, I put this stuff out. How do I deal with these things from there? You need to be ever vigilant. You need to understand the dynamics of what do you do to go after that stuff from there. And the interesting thing that sort of we discovered is sort of the convergence of the environments, meaning how do you take knowledge from software, from hardware, from how things are put together? For example, I go back to the costing issue. If I'm building an integrated platform and I'm using IP that comes from a cheap location, is there a bug in it? And that bug doesn't manifest itself later until the process, very similar to software, or there's combined things to do from there. So how do I understand the supply chain of my technology in such a way that I can vet it? And what can I do to make sure that I have strong integrity with that stuff from there? DoD is responding with a number of initiatives there. I won't get into them, but this is a whole idea to push off and see what they can do in this space. Language talked about, okay, how do we get trusted electronics? Again, and this has been a push on what can we do to make this stuff happen. There's a group within the parts of the DoD talking about trust and assurance microelectronics. How do we deal with different types of technologies? How do we do availability, assurance, integrity, and other aspects as you move forward with that stuff from there? Within the trust area, talked about the low volume, high mix production. DoD does a lot of different types of parts together. How do you ensure the integrity of that stuff as it moves forward with that? And you started to see some of the stuff out of DoD. The challenges is it DoD specific, which means it's hard to get buy-in from the commercial industry, yet you're going to need to do that stuff as it goes forward. And got a couple more slides. Zero trust is one of the things that's sort of been a big push within the department of, can zero trust work in the microelectronics space? And so taking one of the things that's happened within the department is the idea of, can you apply zero trust from the software space down to hardware? What makes sense to do down that path? It used to be that we build a fortress in which we trust everybody inside that fortress, and once you're inside the fortress, now the assumption is you don't trust anybody, and you have to do the analytics to ensure the integrity of the stuff as you go forward. That's being developed as we speak, trying to put the parts together to make it happen from there. This is just a brief slide that talks about some of the programs at DARPA that have touched upon supply chain. Trust talked about the assumption that there were invalid tools and other things associated with the design, and you wanted to be able to detect issues associated with it. Iris said, okay, what if I wanted to ensure the integrity of the design points? And then Shield was, what do I do when I deploy the technology and I want to ensure that the technology that was developed was exactly what I expected and hasn't been tampered with. So imagine you took a passive RFID and add encryption and other capabilities to go down that path from there. So the idea is, if I looked at the design cycles I talked before, can I protect the integrity of that design cycle and ensure what happens from there? DARPA is about proving it out, and now there's various efforts within the department to take it forward. So my last slide just talks a little bit about the capabilities that Booz Allen offers in this space. So we work with clients to talk, both commercial and defense clients, to talk about, what does microelectronics technology and trust mean? How do you understand that and apply that to various environments to look at security? A lot of this is outrage in terms of education as such. So for example, what's the convergence between safety, security, things like that? What do you do with that information? A big part of this is also technology protection. How can you create techniques to ensure the integrity and protection of the technologies you move forward from there? So the first two are very focused on the specifics of the technology. The third is the formalism of supply chain risk management and to make that stuff happen the right way from there, making sure you understand the risks in the landscape of the actual companies and where you go forward from there. Points of contact are Doug Palmer and myself below with the emails listed. Thank you very much. Jeff, are there any questions?
Yeah, I'll encourage people to enter questions in the Q&A, as Ira said at the start. One thing that comes to mind, you talk about all these different efforts across the government. Do you see approaches or theories that are too divergent in the various agencies and everything across the government that make this more challenging, or have people gotten pretty focused and kind of know what to do, or where do you see things standing there?
I think right now people have ideas. There's no consistent theme that's being implemented across the department. Various DoD folks are trying to figure out what makes sense to do, and there are a number of efforts that are trying to be pushed forward as they look out from there. One of the big challenges is simply understanding the scope of the problem and what do you do for various platforms, not only future platforms, which in a sense are the easier problem, but platforms that are underway for development. You're in the middle of building something, but more importantly, you've already allocated the appropriate amount of money, so you can't really get more money unless there's a clear definition as such. And finally, the harder problems is the maintenance aspect of it, i.e., what can you do in this space to go down that path from there? And so a lot of what's happening now is it goes back to this understanding the supply chain and understanding who or what's involved with it and the integrity of technology. The thing I'm most excited about is people recognize it's not the company only, it's the technology. And the question is, what can you do to understand the technology? How you grade the technology is an open question.
Okay, thanks. Do you see the government likes to have standard procedures for things, but do you see standards making sense here, where someone, where the government develops a broadly used approach that gets applied everywhere, or is it sort of that's not really the right approach here? What do you see happening there?
No, it's a great question. I think the government would like standards. So, for example, there is a desire to find them. They would love to have a standard that they can go, if we follow this, it's good to go. Just to give you an example as a side, parts were mill standard qualified, and then they realized that people don't build those anymore. So they went to industrial standards, and that was sufficient. So the goal is, are there things out there that make sense? So for example, NIST and others have standards that potentially have value here. The dynamic is, I've got an organization that's part of the supply chain, meaning, they provide electronics, they provide other items as such. So what do I do when it's a standard that's for the company, not just for the company? It doesn't handle the microelectronics piece. So can I take advantage of that? Yes, I'm sorry, it's a long-winded way to say yes, they would like to find a standard. It's not clear what it is right now.
Okay, we do have a few questions coming in here. One, does DoD have a methodology for handling sole source parts?
That's a great question. So the answer is yes. It depends on the program. One of the dynamics, and I'll answer it in two different ways. If people want a sole source part, there's a mechanism by which you do a justification to do it. And then you can make that happen that way. It just takes time. I'll answer it slightly differently and say the following. If there's only one source for the part, then it opens up a whole set of can of worms, so to speak, about do you rebuild the part, do you replicate things, or do whatever makes sense from there. So there are a number of ways to approach the problem. Some have been more successful than others.
Yeah, okay, thanks. Next one here. How do you handle the fact that some of the assembly methods are antique and the software is obsolete for DoD?
So some cases they literally replicate it and they go out and try and buy all the parts and build it all over again. I know of situations where they've taken stuff that was state of the art circa late 60s and keep it maintained, even though the technology that comes out of it only lasts for a set period of time. The big challenge in this area is requalification. One of the things that DoD is quite stringent about is if it's going to deploy something, it has to be qualified.
Right.
So if you want to replace it, you're going to have to get it requalified. So who's going to pay for that? It's almost easier to pay to maintain something that barely works.
Okay, interesting. Okay, another one here. What type of supply chain modeling tools are being used to model counterfeit risk, and how those models are tested and verified?
So that's actually a question I probably want to take offline because it's some Booz Allen tools, and
Okay.
our Marcom people made me pull a slide about that. So I apologize.
Okay, but there are tools that do this analytically.
Yep. Yep. And a lot of it now is the data analytics plus people are starting to try and look at the AI and machine learning question. I do believe one of the other panelists might be another great person to ask that question about.
Okay, thanks. And let's see, we have couple more maybe quickly here. What are the deepest in the silicon semiconductor technology solutions to protect the silicon intellectual property? Is the area improving for the future?
So I'm not sure I understand the deepest, what that refers to there,
Yeah.
but the area is definitely improving for the future. There's a lot of research that's going on that the department sponsors in this space because that's viewed as a critical area. There to protect that IP and understand what makes sense from there.
Yeah, I think there's current programs at DARPA and elsewhere, right? Things like that. Okay, and then maybe just one last one here. Follow up on the previous one about obsolete. That last statement, pay to maintain something that works, does not make sense to me moving forward. Wouldn't it make more sense to redesign?
That's a great question. The answer, yes, it makes more sense. But the circumstance, for example, is a program needs to remain operational. And so it does at the time what they can afford to do. It's a clear cost to find as such from there. It's not a great answer, but the department is trying to, we're involved in a number of efforts where they're trying to do redesign where they can get funding to make it happen.
Yeah, right.
So
Okay,
thank
well,
you.
great, thanks. So we'll wrap it up there and move on to the next speaker. Thank you, Saverio.
And once again, I would like to thank our sponsors, Omcore Technology and Advantest, who made these presentations and this workshop possible. So thank you, Omcore and Advantest. Omcore has multiple differentiators as a leading OSAT in areas of technology, quality, and services. And Advantest is voted the best ATE company in 2020 based upon the VLSI research rankings with high rankings in multiple categories. So congratulations to Advantest. So I would like to thank them as sponsors. And I would like to once again thank you for attending and look forward to seeing everybody here again tomorrow, and have a good rest of your day. Thank you.